Prior to the 9th century, mathematics was largely a collection of isolated puzzles. Scholars relied on intuition, guesswork, and memorized tricks rather than a unified set of rules. But as the Islamic empires rapidly expanded, so did their administrative challenges. They needed reliable ways to calculate complex legal inheritances, survey sprawling agricultural boundaries, and manage intricate commercial trade. The old, chaotic methods were breaking down under the weight of a highly organized society. By the year 820 CE, the intellectual epicenter tasked with solving these structural crises was the House of Wisdom in Baghdad. Here, a scholar named Muhammad ibn Musa al-Khwarizmi set out to write a systematic manual. His goal was to create a logical framework designed for everyone to learn and apply to any mathematical challenge. He titled his work, The Compendious Book on Calculation by Completion and Balancing. Al-Khwarizmi was attempting to build a universal operating system to govern the practical needs of a growing civilization. To build this framework, he reduced the complexity of mathematics into two foundational operations. The first was called Al-Jabr, meaning completion or restoration. This diagram illustrates Al-Jabr in action. It is the act of removing a negative quantity from one side of an equation and moving it across the equation. By moving the term, you make it positive, restoring the balance without dealing with negative numbers. The second core operation was Al-Muqabala, meaning balancing. Continuing with this scale visualization, we can see Al-Muqabala is the process of simplifying the equation by stripping away identical equal quantities from both sides. What remains is the most direct form of the equation. With just these two algorithmic tools, Al-Khwarizmi proved that the infinite variety of mathematical questions could be categorized into just 6 standardized forms. Because zero and negative numbers didn't exist as independent solutions at the time, all 6 forms relied strictly on positive values. By compressing infinite numerical chaos into 2 specific rules and 6 structural forms, he established a repeatable, logical pathway to arrive at the correct answer, eliminating the need for guesswork. Remarkably, Al-Khwarizmi achieved all of this without a single mathematical symbol. There were no X's, Y's, or equal signs anywhere in his text. Those shorthand symbols wouldn't be invented for hundreds of years. Instead, he wrote out every calculation and operation entirely in prose, giving precise written instructions that anyone who could read could follow. But providing written rules alone was not enough. He wanted to provide undeniable proof that his arithmetic methods were universally correct, so he translated his arithmetic into physical geometry. This manuscript page shows exactly how scholars visualized abstract math in antiquity. Al-Khwarizmi utilized hand-drawn geometric diagrams, like squares and rectangles, to physically demonstrate why his algebraic steps worked in reality. This animation illustrates his method. By taking lines of a given length to form a square, dividing it into smaller rectangles, and locking them together like puzzle pieces, readers had visual proof of his formulas. Grounding the abstract rules of calculation in the tangible properties of geometry turned theoretical math into something you could see and verify. The second half of Al-Khwarizmi's manual leaves the library and enters the 9th century marketplace. He dedicated a significant portion of his writing strictly to solving the practical problems encountered by ordinary citizens. He provided step-by-step instructions on how to calculate complex inheritance distributions according to Islamic law, establish fair business partnerships, and settle commercial debts. This brass astrolabe highlights the era's advanced focus on measurement. Al-Khwarizmi applied his formulas directly to land surveying, giving farmers and builders the tools to accurately measure property boundaries and agricultural areas. Centuries later, his manuscript was translated into Latin and made its way across Europe, where its efficient logic eventually replaced ancient Roman arithmetic entirely. His linguistic legacy is still embedded in the language we use today. The Arabic term al-jabr was eventually translated into the English word algebra. Al-Khwarizmi's lasting achievement was the creation of a repeatable, step-by-step system for problem-solving. This approach, defining a logical path to a solution, is the core principle behind the modern algorithm. Whether we are balancing a budget or writing software, we are utilizing the same structured thinking first documented 12 centuries ago.